look at an example of how we can answer questions using this normal distribution and the rule that we just went over. If we know that the distribution of heights of women is approximately normal with a mean of 65 inches and a standard deviation of 2.5 inches, we can draw our normal curve. And they're not the easiest things to draw, so just get something that looks somewhat similar. And we'll put 65 there exactly in the middle. And then I will do 3 marks to the right and 3 marks to the left, where that first mark is happening at approximately that little point where it changes curvature. What we know is that those marks are 1 standard deviation going each direction. So I'm going to add 2.5, the standard deviation. 65 plus 2.5 is 67.5. Add another 2.5, we get 70. And add another 2.5 and we get 72.5. We can then go on the left by subtracting 2.5. So we get 62.5, 60, and 57.5. Now what I always do on these is I start by drawing this curve, and then I draw in the little lines, and I go ahead and put in the percentages. I use the ones that are split because that will help us answer any of the questions. So now if we wanted to answer the question, how many women are between 65 and 67.5 inches, that's this region right here, and so we know that is 34%. Now we don't know the total number of women here, so we don't know it's 34% of what, but we do know that it's going to be 34% of the total. If we want how many women are shorter than 65 inches, there's 2 ways to think of this. 65 is right there in the middle, and so 50% will be below that. But you can also add 34 plus 13.5 plus 2.35 plus 1.15, and you'll also get 50%. How many women have heights less than 67.5 inches? Well, we've already figured out that 50% have less than 65. We really just need to add this additional 34. And that tells us that 84% of women are shorter than 67.5 inches. If we wanted to answer the question, what percent is between 60 and 70, then we've got these 4 regions get us between 60 and 70. That's also 2 standard deviations, which means we'll have 95% when we add those 4 numbers together. And then if we want to go between 57.5 and 72.5, then we need to go out 3 standard deviations. When we add all of those up, we get 99.7%. So you'll have some questions in your notes where you need to apply this normal distribution and set up your curve with your mean and your standard deviations and just determine the percentages for the information that you are looking for. Well, another thing that we can look at is this idea of a standard score. So the reason we would have a standard score is because we are trying to compare 2 things that come from different distributions. So we could look at something like the SAT score. So if we knew that Madison scored a 600 on the SAT Math College Entrance Exam, and we wanted to know how good of a score this is because 600 is kind of a weird number to give to a score. Well, what we could do is we could know that the normal distribution is supposed to follow the SAT is supposed to follow a normal distribution with a mean 500 and a standard deviation of 100. So how many standard deviations above the mean is Madison? Well, if the mean is 500 and she is 100 above that, that's exactly 1 standard deviation. So we could then ask the question, what percent of students did Madison score higher than? Well, let's think about our curve. She's right here, 1 standard deviation above the mean. And so we know that the mean gives us 50%, and then from our picture, we know that we gain another 34% going up to 1 standard deviation. So Madison's score is higher than 84% of all test takers. So that's a really good score. So that's one way we can think of these type of questions, but an easier thing to do is to come up with what is called a z-score. So your z-score is just going to tell you through a calculation how many standard deviations above or below the mean an observation will lie. So to find your z-score, you're going to take your observation minus your mean and then divide by the standard deviation. It's really important when you do this in the calculator to do the observation minus the mean first, then divide. You've got to do this in 2 steps or you will get the wrong answer. Okay, you have to do observation minus the mean and then divide to get the answer. Now, a few things to note here. If you have a positive z-score, then it just means that the observation is above the mean. If you end up with a negative z-score, it just means that the observation is below the mean. Now, we usually only use standard scores for roughly symmetric distributions. Otherwise, they just aren't all that meaningful. So an example of where these standard scores could be really helpful is if we were trying to compare 2 different tests. So here, Madison took the SAT, but Gabriel took the ACT. Who did better? Well, we can answer that question by calculating everybody's z-scores. So Madison, her score was 600, the mean was 500, and then we divide by 100. So in your calculator, you would do 600 minus 500 and hit enter. That gives you 100. Then you would divide by 100, and she has a z-score of 1. That z-score means that she is 1 standard deviation above the mean. Then we can look at Gabriel, and he scored a 21, but the mean on the ACT is 18 and the standard deviation is 6. In your calculator, take 21 minus 18, that gives you 3. Then 3 divided by 6, you get 0.5. So even though Gabriel did better than the average, he only was 0.5 standard deviations above the mean. So that means that Madison actually scored better relative to the other people taking that test.